From here to the stars, I am your host, Stephen Euin Cobb. Our guest today is Matthew S. Williams. He is a science writer for Universe Today and the curator of their Guide to Space section. His articles have also been featured in Science Alert, Real Clear Science, Gizmodo, IO9, Popular Mechanics, Phys.org, Hero X, and Business Insider, with topics ranging from astronomy and earth science to technological innovation and environmental issues. He is also a podcaster, producing a show called Stories from Space. He also writes science fiction/mystery novels, such as The Cronian Incident. He is also a former educator and a fifth-degree black belt instructor of Taekwondo. I will have many questions on these topics, but first I want to ask a few questions about the chapter you wrote concerning terraforming for an upcoming book which is being edited by Les Johnson and Ken Roy. Your chapter is titled Terraforming Planets Under a Red Sun. Terraforming is, of course, a topic many astronomy buffs are familiar with, at least to some degree, but there are several peculiarities of red stars, also known as M-class stars, which will make terraforming their planets particularly difficult. What are some of the peculiarities?
Well, M-type stars, aka red dwarfs, they are quite, compared to our sun, they are smaller, they are cooler, they are dimmer, and the light they emit is predominantly in the red and infrared end of the spectrum. And so, there are concerns that planets that orbit them, that there's not going to be the right kind of light to power photosynthesis and to help life get going, because what we've learned about life on Earth is that the earliest organisms were simple single-celled bacteria that relied on photosynthesis either from chlorophyll, the green kind, or retinol, the purple kind, and they took in radiation at certain wavelengths and then used that in order to produce oxygen, and thus giving rise to the whole life cycle of Earth. So if in fact red dwarf stars don't have enough of the right photons for photosynthesis to occur, it could very well be that life can't emerge around them. It's based on what we know. And also habitable planets around red dwarf suns, because they need to orbit much closer in order to be within the habitable zone, where they can get enough warmth and light there that they are able to maintain water in a liquid state. That puts them at a distance where they're going to be, in all likelihood, tidally locked with the star. So that means one side is going to be facing towards the sun at all times. And this could have very serious consequences for the possibility of life on the planet too. One side is going to be heavily irradiated 24/7. The other side is going to be dark and cold. And so there's a lot of concerns about whether or not heat will be able to circulate around the planet and get to where it's needed. Sorry, don't know what's wrong with my throat today.
That's all right.
Yeah, no. And last, there is concerns that red dwarf suns, or the planets that form around them, may in fact have too much water, and that given their distance, assuming they're within the habitable zone, this could be a good thing as far as heat transfer is concerned. It could mean that a lot of water is evaporating and forming these nice fluffy clouds. But if they are too close, it's likely they would become steam worlds, where the planet is just a hot mess with a runaway greenhouse effect, because all that water has become part of it's been evaporated into this really dense, steamy atmosphere. And if they're too far away, they're going to be ice balls. But no matter what, there may be too much water there for life to take off, because the oceans are going to be incredibly deep and there's no continents, there's no transfer of heat and energy between the mantle and the ocean floor. So, and on top of that, there's the fact that red dwarf suns, they're prone to flare activity, and some really powerful ones. And those mostly come from the poles, so outwards and not really hitting their planets, but still the radiation environment, it's kind of iffy. So yeah, planets that orbit red dwarf suns are going to have a lot of challenges They're
Okay.
they're they're incredibly common because red dwarf suns make up 75 to 80% of all stars in any given galaxy. But yes, the challenges are particularly significant.
Okay. Okay. Before we go too far into the details of other star systems, let's talk about terraforming within our own solar system, beginning with an easier planet to terraform, if the word easy can ever be used to describe terraforming. For example, the planet Mars. What are some of the steps needed to terraform Mars?
Well, yeah, our solar system does present some. I'd say easy is fair,
Mhm.
comparatively easy to a lot of other places. For Mars, we know that Mars was once habitable. At least all the evidence points in that direction. So it was warm enough. It had a thicker atmosphere. It had water on its surface. So terraforming Mars basically means restoring it to its former glory. And so the way to do that, and the first three steps, they are so beautifully interconnected. You'd make any progress in one, you're going to make progress in another. So the process there is thicken the atmosphere, warm the atmosphere up, and melt all the ice and permafrost to create flowing water once again. And yeah, like I said, anything you do for one of these is going to have nice benefits for the other. So a pretty straightforward one would be, well, let's first of all, it would be nice to have a magnetic field protecting the planet. So NASA has actually looked at proposals to put a magnetic shield between Mars and the sun at its L1 Lagrange point, so it would be constantly protecting Mars from solar wind, which has been slowly strips away its atmosphere over time. And this has been happening since roughly 4 billion years ago when Mars lost its magnetic field when it became largely geologically inert. And so that will allow the atmosphere to thicken on its own. You then drill boreholes to let more carbon dioxide and heat out from the interior of the planet. You thicken the atmosphere by introducing chlorofluorocarbons is a good one. Methane is another. Ammonia is yet another. And these will allow the atmosphere to retain more heat. And you can also melt the ice caps there. A lot of Mars's ice caps are, in fact, dry ice, so frozen carbon dioxide. Uh, some adventurous people have said, well, plant nukes around the pole, set those off, and that'll release all that water. Elon Musk said that. There are other ways, less brutal.
Mhm.
Yeah, we could use solar mirrors to focus light there. We could put dark like soot or ash or dark plants around them, and they will absorb more heat. And all that carbon dioxide goes right into the air. So more greenhouse effect. So Mars is getting warmer now. The ice is melting, starting to flow. Uh, the step after that is the hard one. It's like we need to convert the atmosphere now. We need to introduce Earth's terrestrial biome. So, but the beauty part of that is it's like, well, we can do that nice and gradually. So we start with greenhouses. We slowly introduce the plants to the surface, grasses that'll anchor the dirt and stop or reduce those pesky dust storms, trees that'll help create a water cycle and enrich the soil, and then of course bacteria, lichens, all those things, and they'll be going in there first,
Mhm.
and then over time slowly introduce creatures. And once you've done all that, it shouldn't really take more than a few centuries. It is a long-term plan, but then Mars is now basically a second Earth, smaller, lower gravity, and we're not sure what that will end up producing, but it would be livable, and people could actually walk around outside without a pressure suit. It's probably still be cold, so bundle up and maybe have an oxygen pack on you just in case. But otherwise, it's be like living in Earth in the colder climes.
Okay. Yeah. Most people can imagine living on Mars in a terraformed Mars,
Mhm.
but Venus, that sounds a little, maybe even impossible. It sounds massively more difficult. Talk about terraforming Venus, if you would.
Yeah. Well, yeah, the process of it is simple, but yeah, actually doing it is a titanic task. But the payoff would be huge. So Venus's problem is that, for one, it rotates in the opposite direction as all the other planets. It rotates very slowly, so it's getting lots of solar radiation into its atmosphere for in one spot for extended periods of time. And that atmosphere is super dense. It's about 100 times as dense as ours, and it is overwhelmingly composed of carbon dioxide and other gases. It's got sulfuric acid rain clouds, so it's basically hell. It is the hottest atmosphere in the solar system, hot enough to melt lead, and it rains acid that will literally melt your flesh. But yes, if a human being could stand on the surface of Venus and not be worried about the toxic atmosphere or the melting, there's still the atmospheric pressure would be enough to crush your skull. So, yeah, unlivable is no exaggeration there. There are, of course, suggestions that say that, well, given how thick the atmosphere is, you could put these floating cities right above the cloud tops. They'd be safe, they'd be warm. You can't breathe the air, so you need to have self-contained habitats, but it's livable, it's doable there. And some ideas that have been suggested said, well, if you do that, then these places could act as terraforming bases. So they could slowly convert the atmosphere. And again, it's beautifully linked, right? You need to, and it's the exact opposite of what you're doing on Mars, interestingly. So you've got to thin the atmosphere, cool it down, and then convert it into something breathable. And again, whatever you do in any of those three, there's going to have benefits elsewhere. So a couple ideas that have been proposed. There's introducing hydrogen gas and iron aerosol into the atmosphere, and this would convert it chemically into water and also graphite, which you got to get rid of because that's just going to muck up the works over time. But yeah, if you do that, if you just put enough hydrogen in the atmosphere, there's going to be the long rain or the big rain, and that's going to cover the surface with oceans. And yeah, various geologists and space scientists have produced maps of what that would look like just based on the elevation. And it's like, oh my God, it's a beautiful, lovely planet there with all these archipelagos and a few smaller continents. It would be like an ocean paradise world. And another possibility there was calcium and magnesium. You put those into the atmosphere, pump them in like a aerosol, and that will produce calcium magnesium carbonates, take a lot of the carbon dioxide out of the atmosphere. And you still have to put in oxygen and nitrogen to make it breathable to us. Let's see. Otherwise, there's any number of ways you could chemically convert the atmosphere, and that would have the effect of just reducing the atmospheric density and making it something that's not horribly toxic or horribly, horribly hot. So basically, yeah, opposite of Mars, stop the greenhouse effect on Venus. And you can also, if you are willing to use orbital mirrors again to deflect sunshine, you can actually cool the atmosphere to the point where all of that carbon dioxide becomes dry ice and it just rains down, falls to the surface in chunks, and then you can lift it off. And so all of that, though, yeah, it is a titanic effort, but it is something that can be done over time by bases that are established in the clouds, kind of like Mars. If you put surface habitats there, you can do this gradually over time. And when you're done, again, Venus would be a habitable world, an ocean paradise. You may, in fact, also want to speed up its rotation and get it rotating in the same direction as the other planets so that it has a 24-hour cycle. And that, too, very challenging, but is as long as there isn't a runaway greenhouse effect, basically you're it's okay. You could live there. And slowly the terrestrial life forms could be introduced, and you'd have, of course, a very, very rich aquatic ecosystem. And the gravity is much closer to Earth, so that wouldn't be a problem. So, yeah, Venus would be a lot harder, but the payoff would be really nice.
Okay. Let's talk about shell worlds, which might provide a path for the additional solar system bodies, such as the ice-covered moons of the outer solar system, maybe asteroids. First off, what is a shell world?
Well, Kenneth Roy, who is a scientist and also the co-editor of our new book, he proposed this many years back, and the idea is if you can build an external shell around a planetoid or a moon, even a large asteroid, and now you can contain an atmosphere inside that. And so you don't have to worry about the atmosphere getting lost to space while you're terraforming on the surface. And so inside that shell, you'd have artificial light being generated at the right frequencies, ultraviolet and visible and infrared. And then you get down to the surface of this body and you start to work. Now, one thing that is possible with like the icy moons of the outer solar system, you could actually melt the ice and then you'd have an ocean world. That's not really preferable for a lot of bodies. You'd end up having really, really, really deep oceans, and once you open that up to space, it's likely to just get lost. But what you can also do is you can cover all that ice with some nice soil, some nice regolith, and you can create a surface a few inches thick to be insulated. And then you can start building on top of that. So you've turned an icy moon into basically a small planetoid and introducing life forms on the surface. And in the meantime, of course, you've got this self-contained atmosphere around it. So if it's rich in oxygen and nitrogen, you can put in earth plants, animals, and people. They will be able to breathe that. And then the idea then is that by the time you're done, you take the shell off, and this whole body with its atmosphere and its livable environment, it stays that way. And yeah, that is a very good idea for satellites that are airless, that really have little to no atmosphere to speak of, and would need some serious engineering on the surface, right? You can't just sort of sit back and introduce some things and let nature take its course. You gotta really engineer it.
Hmm.
And yeah, that too, that could extend the whole terraforming concept. And that was the point of his proposal. It extends it beyond rocky planets closer to their suns and all the way up to the edge of the solar system or any system you have to work with.
Mm-hmm. A few years ago, I was at LibertyCon. Ken Roy was giving a lecture on terraforming. Terraforming the moon was one of the topics he covered. And that was the first time he mentioned, or I heard him talking about shell worlds. And he talked about building like a dome, a huge dome on the moon, and then attaching other domes to it, until you cover the entire moon with basically a shell.
Mm-hmm.
Because Mars
Yeah.
can, of course, gravitationally hold on to an atmosphere,
Mm-hmm.
but the
Yeah.
moon can't. And apparently that was at that point, the main goal for the shell. Yeah.
Mm-hmm.
The oxygen in Earth's atmosphere is generally believed to have been a byproduct billions of years ago of single-celled organisms. You mentioned in your chapter abiotic oxygen in an alien atmosphere, that is oxygen that is not a product of biology. Is this just theoretical, or do we have some kind of solid evidence supporting this idea?
It is theoretical, and it's one of many studies that have been done for planets orbiting red dwarfs. In lieu of direct exploration or direct imaging, where we can actually see red dwarf planets, which is coming. I mean, that day is coming. But yeah, in the meantime, it's like, well, given all the rocky planets that we found orbiting within the habitable zones of red dwarfs, like Proxima b right next door, TRAPPIST 1, which has got 3 or 4 of its planets are in that habitable zone. And so, yeah, there's been a lot of theoretical work being done on, well, could these in fact be habitable? Could they hold onto an atmosphere? Could they retain water? And there is lots of evidence to say that, well, yeah, you can find oxygen in an atmosphere that is the result of the chemical breakdown of water by radiation, by the star's radiation. I mean, we see it in the moons like Europa. They've got surface ice. They're hit by solar radiation, and they retain oxygen around them, and the hydrogen is lost to space. So this has been theorized for red dwarf suns. It's like we may find oxygen, or we will be able to infer its presence there because hydrogen is being lost to space. But this may not be a biosignature, as it's called. This may not be something produced by life forms. It could just be the result of interaction between the sun's radiation and water on the surface. Now, a particular study which really stuck with me there was that red dwarf suns, they take a long time to get into their main sequence phase because they're much more long lived, they're much more slow burning. So by the time it gets into its main sequence phase, where it's going to be nice and warm and cozy for the planets in its habitable zone, it's like, well, those planets were in what we thought was the habitable zone, but that's changed now that the star has matured. So anything that's particularly close to it is now getting hit with a lot of heat and radiation, and so that could drastically cause all that water on its surface to start breaking down chemically. And now we have an atmosphere that's going to be filled with oxygen, but that's not necessarily a good thing because all the earliest life forms on Earth, they were emerged, they breathed the carbon dioxide and produced oxygen as a byproduct. Could that life emerge in an oxygen atmosphere? No, because that's toxic to them. And we know this from the great oxygenation or the great oxidation event on Earth. And it's that, yeah, after all these photosynthetic organisms produced all this oxygen, they produced too much, and there was a mass extinction. So life kind of leveled off, and the atmosphere stabilized in what we see today. And so this could be very good for Earth organisms today. They could be introduced to these planets, and they would take root, and they'd be able to breathe all that oxygen. But it would mean that these planets are not likely places to find any indigenous life. So life could live there, but not emerge there.
Okay.
So that created the whole transiently habitable planet scenario. And so, yeah, we could transplant our biome on these worlds and see what happens. But if it's an astrobiology mission we're interested in, they're not likely to find much.
Okay. You mentioned a few terraforming possibilities. If you would, I have a short list: Proxima b, Barnard Star b, Ross 248, Trappist 1. If you would talk about a little bit about some of the features that we know about these objects, and maybe some others.
Yeah, well, there's a lot of uncertainty, right? There's a lot that we don't know, but what we have learned in all these cases was that these stars, using what's called the radial velocity method, which basically measures the movement of the star, astronomers have been able to infer that there are planets orbiting them and pulling on them. That's why they move back and forth. And from that, they were able to get estimates on their size, or not their size rather, but their masses. And so it's like between their masses and the distance that they orbit and some rough size constraints, we start to get a picture of what those look like. So Proxima b, it is a rocky planet. It is roughly the same size and mass as Earth, we believe. It's part of what we now believe is a 3-planet system, because astronomers have detected a strong signal for a gas giant orbiting beyond it, and a small Mars-like planet orbiting closer to the sun. So it's got a planetary system that's really quite interesting, and possibly a debris ring. So it's got several features that our solar system does. So this big, nice gas giant could actually capture asteroids heading in and take the hit for Proxima b. Jupiter's done that for Earth many times in the past. And so in terms of what Proxima b would look like, we're almost certain that it's tidally locked, so that it's got one side facing towards the sun at all times, and that there is a good chance water exists on that planet. So again, it's like, well, one side's facing towards Proxima b, one side's facing away. Unless there is plenty of water and a nice atmosphere, the heat's not going to get around. So it's probably really desertification on one side and ice planet on the other, but that would still leave a nice strip of habitable land on the terminator, the boundary between day and night. So that is something that it's like life could theoretically emerge there, or we could end up living there in perpetual twilight with just enough heat and just enough water. And that's not a bad prospect. As for TRAPPIST-1, so three or four of the planets are roughly within the habitable zone, right? Hang on, let me get a diagram up so I can actually name them. Yeah. Yeah. And so the ones that are actually in the habitable zone, there's D, E, and F, and we have rough mass estimates and size estimates for them. So planets E and F are considered to be most Earth-like. They have a mass and gravity closer to Earth. D is also believed to have plenty of water, but it's smaller. It's more Mars-like in terms of its gravity and conditions. So ultimately, any one of these planets, they're all believed to be tidally locked or to have an orbital resonance. That means that one side is facing towards the sun for a very long time before it gets into nighttime. So again, the possibility that they would be habitable is questionable, but yeah, the main question there is that could life emerge under these circumstances? It's hard to say, but it is entirely possible that they could be transiently habitable as far as Earth organisms are concerned. And what's really interesting too is that these planets, they are all in a very nice orbital dance around its sun. If you were to look up at the sky, you would see the neighboring planet as clear as you would the moon in our sky. And yeah, the closest one would appear like the moon, and the rest would appear as more distant dots. But it'd be an amazing sight. And to think, it's like those aren't satellites. That's right next door. That's the planet next door. We humans really can't fathom that very well because, of course, Mars and Venus, they appear as bright dots in the sky, and that's it. And yeah, the ability for life to transfer in these systems would also be. I've seen some theoretical work that says, yeah, if any one of them got life on them, it could be transferred by lithopanspermia, just rocks breaking off and scattering the building blocks of life to the nearby planets. So yeah, it's that too is a very fascinating system.
Yeah.
All the rest, it's the same thing everywhere you look. Basically, it's like, okay, well, exactly how close are they to the sun? How much heat distribution could there possibly be? And yeah, the uncertainties, of course, it's like, well, this really depends on whether or not it's got an atmosphere in place, and it would be really nice if they had magnetic fields, because that would really help with the radiation and the flares and so forth. So yeah, optimistically, it's possible all of these planets have life on them in some form. Yeah, pessimistically, I'd say, well, at best, they're transiently habitable. But yeah, realistically speaking, it's like, well, either one of those is kind of good. So if we just sort of aim down the middle there and say some life, also habitable, that would be an amazing find.
Yeah, yeah. You write articles for Universe Today, a popular non-commercial space and astronomy news website founded by popular YouTube personality Fraser Cain. It features astronomy news and space-related issues. In addition to writing articles for them, you were also the curator of their Guide to Space section. I'm curious, how did you get into that gig?
It's really quite interesting, but a friend of mine who I knew through Taekwondo, she and Fraser were married at the time, and we got to talking. We met one day, and he took a serious interest in the fact that I was an aspiring science fiction writer, and he took it upon himself to give me advice and sort of mentor me through the whole process of, okay, you've got your writing, which I've been doing since about the age of 19. It's like you've got your work, you've got, you know, some things you are proud of here that you like, that you want to get out there. Well, don't wait for a publisher to find out about you or what have you. Go directly to the market, do the independent writer thing. So I started doing that. And while I was doing that, he also said, you know, you could come and write for us sometimes, do articles. So that's what I started doing. I started doing these general knowledge articles for the Guide to Space, which is sort of Universe Today's general knowledge questions. What is this? What is that? All about planet Earth, planet Mars, etc. And yeah, about 2014, we were reconnecting one day, and he said, he had noticed that what I was doing on my own website there, the kind of writing I was doing, he's like, it's very close to what we do here at Universe Today. And we're also, I'm launching with these guys called HeroX. How would you like to come and write professionally? I said, absolutely. And that was that. And a year later, I had been an on-call teacher at the time. A year later, I decided to step out of that role and become a full-time, all-in science writer. And yeah, Fraser had then decided we need someone to curate the Guide to Space because it's been evolving and there's so many articles there now ever since the early 2000s when he started the website. So yeah, can you start organizing it, modernizing it, and all that stuff? But yeah, the real, over time, my real role was just, you know, cover the stories, cover the big stories, cover the issues. And yes, HeroX, they eventually hired their own staff, so I migrated from there. And I also started writing for Interesting Engineering. I want to include that. That's not in my original bio there. Yeah, and by 2019, I also started writing for Interesting Engineering, which is a very large and more general kind of science publication. It talks about all aspects of scientific and technological research. And yeah, and much to my surprise, over time, I began to notice other people were republishing my articles, and I thought, oh, that's wonderful. Let me think here. What else do I want to say about that? I think that's about it.
Okay.
Wait. Actually, yeah.
Okay.
And yeah, and over time, not only did my day job inform my personal writing, but I began to focus. I began sort of garnering certain areas of focus, which included terraforming and how I came to Les Johnson's attention, and also interstellar exploration and just anything that really has to do with the big stuff, the big speculative stuff.
That was Matthew S. Williams. This has been From Here to the Stars, a video series created by the Interstellar Research Group. The IRG is a non-profit organization dedicated to thoroughly exploring the science and engineering that can eventually open up the reality of interstellar travel. Find us online at irg.space. I have been your host, Stephen Euin Cobb. If you enjoyed this video, please hit the like button, and you can subscribe to our channel for other such videos. On behalf of all of us here at the Interstellar Research Group, I thank you.